Plainovate provides teachers of primary school children with high-quality teaching tools for STEAM education. These lessons and hands-on kits are fueled by leading ideas in education and STEAM fields, which include the science of learning, big ideas in science and engineering, and the process of innovation. Plainovate lessons are designed to prepare children to thrive in the era of Globalization 4.0. We make complex science and engineering concepts accessible to primary school children. Engage children in active learning like they are scientists and engineers. Cultivate curiosity, analytical thinking, and creativity. Excite children and nurture their interest in science and engineering fields through discovery, exploration, and innovation. Every lesson is designed according to the Plainovate STEAM curriculum process loop. Here are the 4 parts of each lesson. Engage. Introduce the STEAM concept in a situation or phenomenon in a way that triggers students' curiosity. Ask. Ask a how question. This determines the focus of the lesson on the mechanics and process that leads to exploration. Do. Engage students with hands-on learning. The tools and materials are provided in the STEAM kits. Think. Advance the children's observation, organization, analytical, synthesis, and communication abilities. In this video, our learning design team will be sharing with you the lesson on color centrifuge. Your students will learn what makes color, how does a centrifuge work, and real-world applications of a centrifuge. The introductory simulation on chromatography, or the separation of colors, is a discovery activity on how a centrifuge can, through centrifugal acceleration, cause liquids to divide its denser and less dense substances and particles represented in the activity with color. The second hands-on activity informs students how a motor accelerates rotations. High-speed rotation is key to the function of a centrifuge. It all may sound very complicated, but just like every Plainovate lesson, it is definitely accessible. Enjoy teaching and learning with Plainovate. This is the standard opening slide. Keep this slide on while waiting for the students to join the session. This is the lesson title slide. The teacher welcomes students to the class and reads the title slide, Secret of Colors. Creating community among participants is vital for building a welcoming learning environment. If students are from different schools, ask each one to share their name, school, and grade level. If students are from the same school, ask each one to share their name and birth dates. This slide introduces the class to the concept of STEAM. The teacher explains in this lesson we will be learning not with one subject, but an intersection or integration of different subjects. This is what STEAM means. As you go through the lessons, you will notice how all of these fields are used to learn specific topics. The teacher explains participation means doing, thinking, and sharing ideas, and listening and learning from each other. In every lesson, the teacher guides the class to figure out the problem they will be solving. In this lesson, Tipball, the character on screen, gets into a situation. Ask the students, why do you think the character's name is Tipball? Students guess. Yes, his body is shaped like a ball. Then why tip? Tipball also means clue. He provides clues in different ways, just like this video.
Hi, my name is Tipball. School is about over and I'm excited to go home and show my artwork. Oh my, it's dark out. Yipes, it's raining. I forgot to bring an umbrella. Not sure what to do. I think I'm going to run to my house anyway. 3, 2, 1, here I come. Mom, I'm home. I want to show you my artwork. It's a black panda. Oh gosh. Can you help me find out how this happened?
Ignite curiosity. Ask students, do you have ideas on what possibly happened to the Black Panda illustration? Teacher says, this makes me wonder where the colors came from. Do you know? Can you guess? Encourage at least half of the students respond. Teacher says, which one of these guesses do you think is a possible reason? Ask each of the students to respond. Assure them that there is no wrong answer because these are just guesses. Read the text on the slide. Get 1 or 2 answers from the group. Teacher reads the text on the slide. Teacher reads the text on the slide. How many vote for A, B, or C? Teacher explains. This question will guide our next steps in the lesson. At the end of the lesson, we should all together be able to figure out the answer. At this point, the teacher introduces the concept of simulation. At the end of the lesson, the concept will be compared to the concept of experimentation. Make sure every student has a complete set of materials. The teacher instructs students. Use your markers, 1 color for each filter paper. The teacher instructs students. Watch the video. Make 3 folds for each filter paper. Using the rubber band, tie the folded filter paper 2 centimeters or 1 inch from the bottom. Pour water half full in each of the glasses. Remove the rubber bands and unfold the filter paper. The teacher asks, why are we using swimming competition as an analogy of what's going on with colors when filter paper is dipped in water? Observe the colors in each filter paper. Which ones do you think swam faster to the top? The teacher explains. Each of the colors pass through the filter paper. What happens when a material like powder passes through the paper? What does paper do? Encourage students to give their opinions based on their observations and prior knowledge. Then ask, if colors come from different types of materials, how will this affect the speed of swimming to the top through paper? Encourage students to give their opinions. Then say, materials vary in texture, weight, size, etc., which affect their speed. The teacher instructs students. Let's watch this video. Then asks, why don't we see just yellow, red, and blue? Colors also interact with each other and create different colors. Teacher reads the text on the slide. The teacher instructs students. Do any of you know anything or heard the word chromatography before? After showing the video, the teacher asks, what is the connection of the activity we did with filter paper and colors to chromatography? After students answer the question, the teacher asks, I mentioned the word simulation earlier. What does simulation mean? The teacher says, Tipball thinks we can speed up the process of water separating the colors. Do you have any thoughts of how we can speed up the process? Students answer the question. The teacher introduces the slide by saying, here are some clues. What ideas about speed can we get from washing machine and an umbrella that turns in the rain? Students answer the question. Make sure every student has a complete set of materials. Look for the second packet of supplies and check if you have these materials. Let's think of what we already know about these materials and then relate them to how they contribute to speeding up the process. The teacher guides the students. Let's start building the next part of the lesson. This time, we are building a tool to speed up the process. This activity is called making a prototype. I'd like for each of you to look at the images and videos on the slides and figure out each step first. We are training your observation skills. With your materials, start building. If you have any problems, raise your hand, I will help you. The teacher instructs the class. Watch the video, then figure out the steps. I will click pause on each of the steps so you can build and watch each step. The teacher explains, this is a fun step. This is where you test to see the difference between the simulation without a motor and batteries and your tool prototype. What do you observe? After this lesson, if you have an extra filter paper at home, you can repeat the simulation. Time the process and compare this with a prototype. The teacher explains, take the rubber band off the foam ball and wait for your papers to dry. Assemble them to make a beautiful work of art. The teacher introduces the video. In many places in the world, people have no access to chromatography equipment. People are also very poor and cannot afford to go to hospitals. Also, because they live in communities far from cities, like where we live, they have to walk for hours and then take the bus or train. If the person is sick, this is very difficult, and for some, not even possible. So students in Stanford University created a tool to help these people get well. Let's watch this video.
Scientists have used paper and string to make a centrifuge that could be used for medical tests in remote locations. The centrifuge is an important part of science labs across the world. In healthcare, you need one to separate blood into different parts for further testing. But centrifuges are traditionally bulky and expensive and need to be plugged in. In the quest for an affordable, electricity-free centrifuge, scientists have previously made use of a salad spinner, but this design is relatively slow. Now, scientists at Stanford have been inspired by a simple children's toy that can be made out of a button or a disc of paper. They studied the mechanics of the toy to work out how to achieve the fastest possible spin. The final design can spin at 125,000 revolutions per minute, which is over 2,000 spins a second. Just 90 seconds of spinning is enough to separate a blood sample into red and white blood cells, platelets, and plasma. A longer spin separates out the part of the blood needed for malaria testing. Named the Paperfuge, this device costs just 20 cents to make, out of paper, fishing wire, and wood. Or you can 3D print plastic versions in bulk. Field testing in Madagascar showed just how easy it is to use the device, which means that even remote areas with no money or electricity would soon be using the Paperfuge to perform basic but vital medical tests.
This is a segue to the mind map. Now that we have answers to Tippo's question in the beginning of the lesson, let's send him a letter. Let's work on the letter in the next slide. Ask a student to read the letter. Then ask the class to create their cohort name. Instruct students to get their mind map workbook page and pencil. They will need to draw lines according to this illustration. Start the mind map articulation with a question slide. How can black be a combination of other colors? Go through each of the circles in the mind map. Start with a process. We reviewed rain on tip ball, water on the page. Then ask a student to lead the next part. Assumptions. Ask the class another word for assumptions. Guess from what we already know. Let the student continue. Does rain have colors? Did color fade from the cover? Were the colors in black ink from the black marker? Other ideas? Ask another student to read the next set of circles. Simulation is like an experiment that does not use the actual materials but makes us understand the idea. Chromatography is? Ask the students. And then the application, the blood test. Ask another student to read the last set. Prototype is application, manual centrifuge, inspired by a toy. In this final slide, get a sense of how students felt about the class. Thank them for their active participation. Encourage students to look through the activity pages. Thank them for being curious and inventive, and look forward to seeing them soon in the next lessons.